Now, in this video, we gonna learn about two concepts. That is what is ML and different types of ML algorithms. So these two concepts we gonna understood from this video. So now let's have a question. What is this ML? This ML is nothing but it's just a computer program. What is this ML? It's just a simple computer program. Now let's have a question. Why do we create any programs or why do we write some logics in order to execute our required task, right? Yes. So in order to execute our task or perform our task, we actually create any computer programs or ML. By using this computer program, I will execute my task and I'll generate some results, right? Yes. So let's say I have runned, I have executed multiple tasks and I generated multiple results. So based on these results, I want to create one more computer program where in that program, I want to train the details. I want to train the details based on the previous results. Based on the previous results, I want to train my current creating current creating ML, that is current creating computer program. So in order to execute my task to get my result with high performance, let's say I've created a program and I've executed a task, then I got result. So how do you measure the quality of this result? By using efficiency, right? Yes. By using performance efficiency, you can actually calculate the quality of your result. Now let's say I want to improve the quality. I want to increase the quality of result that I am getting. So what you do based on analyzing multiple results, you can recreate your program, right? Yes. So by training the data into your computer program, you can actually execute your task again to get the high performance providing high efficient result, high quality result, right? Yes. So basically, this machine learning is just a computer program where this computer program learn from trained data. By using this trained data or experience, it will learn. This trained data is nothing but what? It's nothing but the experience, that is a previous generated result, right? Yes. Can I call that previous generated result as an experience? Yes. So by using this trained data, this computer program actually learn how to execute a particular task. So how to execute particular task, that is learned by using what? From trained data. Who can learn that? Computer program. This computer program, what do we say? That computer program which is learning from trained data to know how to perform a task, we call that computer program as ML. So what is ML? ML is nothing but a computer program that can learn from trained data how to execute a task. That is a ML, right? Yeah. So let's create a solid definition for it. So what is ML? It's just a computer program. So what it will do? It will learn. It will learn from, it's just a computer program. It will learn from trained data, or you can say some previous results. It can learn from previous results or trained data, or you can even say that it has an experience. So from that it will learn, and for what it was learning, in order to perform or execute your task, right? To execute to execute task to execute task with to execute task to provide, for providing what? For providing highly efficient performance quality results. So for providing high quality high quality for providing high quality, high efficient, and high performance results. So this is a solid definition that we created from our knowledge. Here you can see, by referring from multiple sources, we created this definition. What is this ML? It's just a computer program where it will learn from trained data or previous results or experience results that are generated. For what? To execute tasks. To provide high quality or efficient or high performance results. Now let's see what are different types of ML algorithms. What are different types of ML algorithms? This ML is nothing but machine learning. The full form of ML is nothing but machine learning. Now let's see different types of ML algorithms. So based on how we are training or how we are learning our computer program, how our computer program is learning. So based on that, these are categorized into three types. First one is supervised, second one is unsupervised, and third one is reinforcement learning. So what is this supervised? What is this supervised learning, sir? What is this supervised machine learning? In this supervised machine learning, actually our computer program will learn from labeled data. If our computer program is learning from labeled data, then we can say that type of learning as a supervised learning. Here you can see, based on by using a labeled data, actually we are learning this supervised ML models. So what is our goal here is, in order to identify or in order to predict that particular labeled data, in order to predict some particular labeled data. Let's say I want to detect, let's say I want to detect a cat, or let's say I want to detect a cat or a dog. So for that, we first train our computer program by using a lot of set of images which are labeled with that cat image as well as the dog image. So wherever that dog image is there we are labeling and we are marking like it's a cat. And wherever dog image is there we are labeling and we are marking it as a dog. So like that, we are loading a lot of data. We are learning, we are training a lot of data into our computer program in this supervised machine learning. And then after, to predict a image, whether it contains a cat is there or dog is there, we are using that training data set computer loaded computer program in order to identify that. So that's the type of identification or the type of machine learning use case comes under this supervised machine learning. In this, we have multiple algorithms are there. That is a linear regression algorithm comes into this, and decision tree algorithm or support vector machines also comes under this. So one more important point that I want to mention here is we use the support vector machines algorithms whenever we are identifying a missing word. Let's say you want to identify the fill in the blank word. So that you can able to identify by using this support vector machines in real time. So by using this algorithm, we can able to identify that. By using this linear regression and decision making trees algorithms, we can able to identify the image classification or fraud detection or spam detection as well. So the major advantages coming to here is your output is highly accurate since we are loading our data or we are training our ML model with a lot of data. So that's why our output will be highly accurate and clear objective. That is a predicting. Clearly we are predicting our output. Either it is a cat image or a dog image. So like that. Whereas in this model, in this supervised machine learning model, we also have a disadvantage, that is we need to train our model with a large labeled data set. A large labeled data set, by using that we need to train our model. And even sometimes it may take very time consuming to label our data as well. Since we are training with a large labeled data set, we need to create the data set, right? Yes. So for creating the data set, we need to label each and every data. That is in this image, this part is a cat, this part is a dog. Like that, we need to label our images. So that may take a very lot of time. That is a highly time consuming, and processing or loading or training that much of data requires a lot of time. So those are our disadvantages if you use this supervised learning. Let's say you want to predict the pattern. You want to predict the pattern in real time. If you want to predict the future pattern, either it may be stock market as well. So in that scenario, you need to prefer this unsupervised learning. You need to prefer this unsupervised learning. Here, we are actually training our model from unlabeled data. From unlabeled data, we are training our model. So by using that model, we can able to predict the patterns. We can able to predict the hidden patterns as well as future patterns as well. Whereas coming to algorithms which comes under this unsupervised learning are k-means cluster and this hierarchical cluster and this PCA, that is principal component analysis, comes under this unsupervised learning algorithms. Whereas if you see the real-time implementation, you can even identify the customer related sentiments. So based on the data that is provided by the customers, you can able to identify the sentiment of that particular customer by using this unsupervised learning model. So not only that, you can see multiple use cases are there, that is anomaly detection, and market basket analysis. And coming to this unsupervised learning ML model advantages, you can find the unknown patterns. That means you can able to predict the unknown patterns, and it is useful for exploratory data analytics. Not only advantages, this unsupervised machine learning also have disadvantages. Those disadvantages mainly are the result is less accurate. The result will be less accurate. And computation or interpretation of result will be very hard here. So these are the two things which comes under disadvantages of this unsupervised machine learning models. At last, we also have one model, that is reinforcement machine learning models. Here, this is actually different from these two. Here, we are learning our computer program based on rewards and punishments. Based on rewards and punishments, we are learning our reinforcement model. Our goal is to maximize cumulative rewards at the end. So for that, we are learning our model by allocating the rewards. If our model is performing the task in correct way, and if our model is performing our task in incorrect way, then we are punishing our model. So like this, we are learning a model, that is a reinforcement model. And the algorithms which comes under this section is Q learning, deep Q learning, and policy gradient model. Whereas examples, if you see, game playing example. Game playing is one of the example. In chess, you can see if you choose one move, then it might leads to wrong. That is, it might leads to end the game, right? Yes. So if you do a wrong move, then it leads to punishment. If you do a correct move, then it leads to reward points. So that is one of the example. And even in robotics, so while controlling a robot, if a robot makes a correct move, let's say you commanded a robot to move forward, but it moved backwards, then what do? So it's a wrong step, right? Then you need to provide punishments for it. And if your robot navigates in correct path, you said forward direction, it also navigates to forward direction, then you appraise it, then you reward it by charging it. So like this, you can able to model your data. And not only that, self-driving cars also comes under this example only. Whereas the advantages are, it learns complex behaviors and can adopt changes based on environmental changes. Based on environmental changes, it can adopt the changes. So those two comes under advantages. It also have disadvantages. So in order to learn from actions, that is from rewards and punishments, it need a lot of data. It need a lot of data regarding successful steps as well as unsuccessful steps. Everything it need to store, and it need to compute that whole data. So that's why computing that whole data is expensive, and providing that a lot of data and training that lot of data is also difficult. And those two comes under the disadvantages coming to this reinforcement learning. So that's the major types. These three are the major different types of ML models. So that's the definition about machine learning and different types of models about this machine learning. Those we covered in this video. I hope this video is useful to you. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.